Okay, welcome to part 2 of our Pythagorean proof video. Thought I'd split it up into two since it's a fairly long exercise. 4a we're up to, and it's another prove question. So we're proving the left-hand side is equal to the right-hand side. We're going to start with the left-hand side, play around with our trig identities, and see if we can get it looking like the right-hand side. Okay, so the left-hand side says sec squared x plus sec x tan x. We're going to start with that and see if we can manipulate it to equal 1 plus sine x over cos squared x. Let's see if we can do it. So I'm going to start with the left-hand side. Now, generally when these questions are written, they're written so that they are doable. They're not written so that we can't work them out. So we can do them. It might take a couple of goes sometimes, or a little bit of trial and error, and that's okay. And of course you guys are learning. Once you get into the hang of it, you'll go and be able to see them a lot easier. Okay, so our left-hand side is sec squared x plus sec x tan x. Now, what do we know about sec? We know it's 1 over cos. So I'm going to write my sec squared x straight up as 1 over cos squared x plus. Now, I've got a cos squared x here, and I can see that I want to get something in terms of cos squared x on the bottom. So what can I do to my right-hand side? Not to my right-hand side, sorry, to the sec x tan x. I can do something there as well. I can write sec x as 1 on cos x, and I can write tan x as sine x on cos x. So I've just basically times those two together. They've come from here, and we're looking good. Because if you can look ahead a little bit, you'll see that my bottom line is also going to be cos squared x, and that's what I want. So let's get that looking a little bit better. So 1 over cos squared x plus, I've got a sine x here. I don't need the 1 anymore, so I'm going to write it as sine x. And my bottom line becomes cos x times cos x. Well, that's 2 cos x's, so cos squared x. And what you can see is our bottom line is now exactly the same on both of our terms of our fractions. So I can write that down there on the bottom, and I can join my top line. And we actually have now formed the right-hand side. So we have proved that already. And now we've proved part A, we're going to move over to part B. And part B starts off with a hence. Now remember last week we learnt what hence means. What does hence mean? Someone yell it out. It means we're using information from the previous part of the question. And that's what we're going to do. Hence prove that sec squared x plus sec x tan x. If you have a look, that's what our question was up here. We've proved that part already, sec squared x plus sec x tan x. Well, now we're going to prove it equals something else. We're going to prove that it equals 1 over 1 minus sine x. But we've already proved this part here. We've proved the right-hand side. So it's saying hence. So I'm going to start with that right-hand side. We don't need to start with the left-hand side here because we've proved it equals something else. So I'm going to write it a little bit different. I'm going to say from part A, the left-hand side equals, I'm going to write down what we had as part A, 1 plus sine x over cos squared x. That's our hence part, okay? Hence, using information from the previous question, we've got this. Let's see if we can now get this left-hand side here equal to this right-hand side. So we're going to play around with it. Now, what do you see? Can you see anything that you can work with? I note the bottom line. I'll leave the top line as it is. Cos squared x. Now, remember, a little note up here, sine squared x, or sine squared theta, plus cos squared x equals 1. I've got a cos squared x. I want to rearrange this. Take sine squared from this left-hand side, take sine squared from the right-hand side, and my rule changes to 1 minus sine squared x is equal to cos x. So I'm going to replace my cos squared x with my 1 minus sine squared x. That's my first step. It's really the only thing that I could do. I don't have any trig identities that I can change around with sine. I mean, there is cosec, but I think that would make it difficult. And our answer over here on the right-hand side doesn't have a cosec, so it has a sine. So I'm going to leave the top line. The bottom line is what we've changed. Can you see something else? Think back to what we worked really hard on in our first algebra topic. What can we note the bottom line is? It's a difference of 2 squares, isn't it? Okay, 1 squared is 1, so that's a square. Sine squared x is sine x all squared. So we can write that as a difference of 2 squares. Our top line stays the same, and our bottom line gets written as 1 minus sine x over 1 plus sine x. Now, remember, if you're some of the students in the class that get confused with this rule, if you don't want to call it the difference of 2 squares, you call it the minus of 2 squares, if that helps you. Remember, there's a minus sign, we have a squared term and a squared term, and that's how we notice that that rule works. So straight off, I can change that to this format here, okay, using our difference of 2 squares rule. Now, I need to think of that top term as one whole term grouped together, so I'm going to put brackets around it. Now we can cross out terms that are similar because we've gotten rid of a plus or a minus on the bottom line. Okay, a lot of you will want to go and cross out that sign with one of these signs here. Remember, we can't do that because we have a plus and a minus between them. They're not multiplied. So we needed to change these so that the terms in brackets were multiplied with each other. We've removed these signs and now we can cancel out. So I can now cancel out this 1 plus sine x with this 1 plus sine x, and I'm left with a 1 over 1 minus sine x. Is that what we wanted? That's what we wanted. That's the right-hand side. So we have hence proved that rule. Okay, moving down a little bit to question 5. It's another proving rule. And on this one, we've got a 1 over cos squared x plus a 1 over sine squared x, and we're going to try and prove that that equals sec squared x cosec squared x. Okay, remember, it's a proof. We're going to start with the left-hand side and we're going to manipulate it and see if we can get it to look like the right-hand side. We're not changing things around at the top from left-hand side to right-hand side at the moment. So let's write down the left-hand side and have a think what we can do. Okay, well, we could go and replace the cos squared x with a 1 minus 1 minus sine squared x, or we could replace the sine squared x with a 1 minus cos squared x. That would be one way, but I'm looking at where we want to head, and I can see I have a sec and a cosec. A sec is a 1 on cos, a cosec is a 1 on sine. So I want to keep things in terms of sine and cos if I can. So what I'm going to try in this case, and we'll see if it works, is I'm going to multiply the bottom line together and get it into a simplified form in my algebraic fractions. Once I've done that, I can cross multiply my tops. Sine squared x times 1 is sine squared x. Cos squared x times plus 1 is cos squared x. And now we are nearly there with the top line. What do we know? Sine squared x plus cos squared x is 1. So that becomes a 1. Our bottom line stays as cos squared x sine squared x. And now have a look back what our right hand side is. We're nearly there. Okay, what we can do is now break up that bottom line, or think of it as 1 over cos squared x times 1 over sine squared x. That's what we're thinking. You might be able to miss that line altogether and go straight to the next one, which is sec squared x cos sec squared x, which is equal to our right hand side. So that one actually looked quite tricky from the start, and it was probably one of our easier ones. Now, that will allow us now to have a start at exercise 5G. Let's have a look at that. Oops, I think we're up here for 5G. So that'll allow us to start working through 5G. Okay. The preferred questions for you to do are in the OneNote. That'll explain which ones to do. There are obviously some challenge questions that I think a lot of you or most of you will be able to handle. Okay. Now, we have got this as a double lesson in terms of we've got 2 lessons to work through these exercises. So, and you've got a weekend in between. So that's going to give you a heap of time to work through that. The other thing that is there for you to have a look at is 5G on the side over here. We've got the trig identities in there as well. There's some extra ones in there if you want to have a look at working through as well. And we've got some more to have a go at. So there's an endless supply for you to have a go at. But start with exercise 5G for me. See how you go. If you've got questions, flick them through. But remember, in our textbook, we have got the worked examples at the top. Okay, so you've got your answers, so you need to check the answers. But more importantly, if you're stuck, there's some worked examples in there to have a go as well. So go and have a go. Good luck, and just persist. Go back and look at the rules along the way if you get stuck.